Okay, this is the test corrections for the momentum test. Number 7. 29 force changes the velocity of 1.250 kilograms slider from 31 meters per second to 56. Over how much time was this force applied? So the force equals 29 newtons. The mass is 1.25 kilograms, and the velocity initial equals 31 meters per second. Velocity final is 56 meters per second, and time equals, you don't know the time. So the formula for impulse is J equals force interval or time, and then the conservation of momentum is the momentum before is equals momentum after. So that's P1 equals P final, or P initial equals P final. Momentum equals P equals mv momentum. So I can write this as P final equals mass velocity final. P initial equals mass velocity initial. Yeah. Okay. So then that will mean it will be P final minus P initial. That's the impulse. Because if there's impulse, then there's going to be, if energy is conserved, then that means there is momentum. Yeah. Okay, so then I'm gonna write this, I'm gonna use this equation. Mass velocity initial or, okay, so I'm just gonna rewrite this equation. Then divide this by F, because you're trying to find the time. This is the unknown. And then I'm gonna plug in what I know. So you know your mass is 1.25 kilograms. And then your velocity final is 56 meters per second. And then you minus the initial, which is 31 meters per second, over the force is 29 newtons, equals delta T. When I plug it in the calculator, I will get, so I'm gonna do 56 minus 31, 25, and then I'll 1.25 times 25 divided by 29. So I get 1.08 meters, or seconds only, because meters cancel out. So 1.8 seconds. Number 8, draw a line, let's do this. A baseball pitcher mass is 80 kilogram at the Galleria ice rink and throws a 0.0145 kilogram baseball straight forward at 70 miles per second while on the ice from rest. What is the final velocity of the pitcher? So the mass of the pitcher is 80 kilograms. The mass of the baseball is 0.0145 kilograms. And then the velocity of the pitcher initial is at rest. So that'll be 0. Okay. And then velocity of the ball initial is 70 meters per second. So I'm going to use the equation m1 v1 initial plus m2 velocity to initial m1 v1 plus m2 v2 final. Okay, and then this will cancel out to be this will be 0 because the mass of the pitcher is 80, but the velocity of the pitcher is at rest, so it's 0. So that will be canceled out to 0. What is also 0 will be the m2 velocity to m2 v2 because so this is 1, this is 2, 1, this is 2. Okay, because it's the 70 is from the velocity of the ball thrown, but you're trying to find the final velocity of the pitcher. So that would be canceled to 0. So you do m2 v2 initial equals m1 v1 final. So m1, that will cancel out because you're trying to find the final. So what you have is m2, sorry, m2 v2 initial over m1 equals velocity initial final. So this will be the mass of the ball. This will be initial velocity of ball traveled. Okay. So I'm gonna plug in what I have. So I know that the mass of the ball is 0.0145 kilograms. And then 70 meters per second, that's the initial velocity is traveled over m will be 80 kilograms, which is the mass of the pitcher. So when I plug that in, I will get 0.013 meters per second because, wait, no, I wrote this wrong. The unit is wrong. Yeah, meters per second. It will be backwards because, so this is left, this is right. So the pitcher is right here and they throw it right. When you throw it right, you will have the opposite reaction to your left. So, and the pitcher is at rest. So that means when you throw it forward, then you're gonna have the opposite momentum will be to the left direction, backwards. Okay, so number 9. I guess I can just explain it down here. Okay. What can be said about a projectile following a certain trajectory that explodes mid-air? So when it explodes, the center of the mass will be here. And then it will go like this. This will also be the center of the mass. So if it explodes, then that means the projectile would fall here, which is the mass. And then when it falls here, then it can like erratically like explode outwards from the original center of the mass. Number 10. A football player of 100 kilograms tackles a practice dummy of 50 kilograms at rest with a velocity of 35 meters per second. What is the speed? With what speed do the two go flying towards initially? So I'm gonna write out what you know. So you know the mass is 100 kilograms. That's the mass of the football player. So football player. The V naught is 0 because it's at rest. And then the velocity is 35 meters per second, and you're looking for time. So I'm going to use the equation m1 v1 plus m2 v2 equals m1 plus m2 vf. So no, actually this is the wrong equation. I'm not supposed to use this one. Sorry. So you know the mass of the mass final, velocity final is equals to the mass of the dummy, and the velocity of dummy equals mf plus md parentheses vf, because this is before the collision and this is after the collision. So what will cancel out to be 0 would be the mass of the dummy, because the dummy is 50 kilograms, but it's at rest, so that will be 0. So then what you will have is, this is canceled out, you will have velocity final equals m final v final over mass final plus the mass of the dummy. So once you add that up, it will be 350 over 150. You divide by 150. Okay, so here's a picture. So this is, velocity is 35 meters per second. There's a dummy. This is 50 kilograms. 100 kilograms. Okay, so 350 divided by, it'll be 2.3, so 23.3 meters per second. Okay, the free response. Okay, the first one. A red car is a mass of 15 kilograms. So the mass of the red equals 15 kilograms. And it moves to the right 5 meters per second. So velocity of red initial is 5 meters per